Hey everyone, welcome back. And in this video, I'm gonna go ahead and discuss about a very interesting feature in React, which is only available in React 18 and above. Also, if you're new here, make sure you like and subscribe to the channel. I'll be creating a lot of content on JavaScript, full stack web development, React, and a lot of similar topics. So if you want to keep yourself updated to this stuff, make sure you subscribe and hit the bell icon. And we're gonna be taking a look at concurrent UI again in React. I did a video on this, I think a couple of years ago when concurrent mode was first announced, but since then concurrent mode has been a little delayed in terms of when it would come out, but when it will come out finally, it will be awesome. And in React 18 you can pretty much opt in into concurrent modes, a few of the features. Now, not actually going exactly into concurrent mode, how it really works and so on and so forth, but what we'll be taking a look at is something known as createRoot in React, which is different and which is what you have to use in order to opt into concurrent mode. So what I want to do here is actually go ahead and inside the codedamn playground, I want to open the index.jsx file and I will just remove the strict mode for now. So the moment we do that, what's gonna happen is you're gonna see that we have this line called react dom.render, then the component and where it should be rendered on the screen. And this is pretty standard stuff. We have discussed this in our React course and full stack learning path as well. But what has changed in React 18, and I'm running React 18 in this one, it's an alpha preview, but I'm still running React 18. What React 18 brings us is that it brings us support of this createRoot. And what this is, like the comment says, is that it allows you to opt into concurrent mode. So we'll discuss what concurrent mode really is once it is a little bit more stable and out in the wild. But for now, let's just opt into this new rendering feature of React. So what you need to do is you can just say, what is my root element? In this case, it's document.getElementById by ID with root. And then what you have to do is say react dom.createRoot and then pass in the root element. And you can say this is my React root, for example, something like this. And you can see right here, once you do that, you can call a .render on this. So let's take a look at what this render, how this render we have to use in the codedamn example. And all I have to do is say react root.render and then this thing right here, right? This could be pretty much any element, right? And like it says that you can also nest them together here as well. So what this does is that it allows us to use these features, which you will be able to see in the concurrent mode table. Let me just see if I can find that table. So yeah, this is the table which shows you the legacy mode, the blocking mode, and the concurrent mode. So legacy mode is the thing which is available right now, right, in React pretty much. So you know that we could reuse suspense in React. Why? Because although it's a concurrent mode feature, but it still is available in the legacy mode. The blocking mode we'll probably not talk a lot about here, because blocking mode is for those code bases who have some custom implementations of a few things and which get broken when we shift to concurrent mode. So it's like a middle ground between legacy mode and concurrent mode. Almost always, if you're trying to create a new project after React 18, you want to start with concurrent mode right away, right? And that's what createRoot does. So there are 2 to 3 modifiers here. You can see the first one is create blocking root. The second one is createRoot, and the third one is just directly render on React DOM. So these respectively just render and just start the ReactJS rendering engine into that particular mode. We'll stick to the createRoot mode. And what it does is one of the features you can see right here, which says us is automatic batching of multiple set states, right? Which is not available here. I mean, it is kind of, we'll see what this means, but this is definitely available in these two. And this is what we'll discuss in this video, how createRoot makes it work. Not exactly how, because that's an internal detail, but how you can make it work. There are so many other areas which are very interesting and we should be exploring in the further videos, but this one I found the easiest and the most interesting one as well. So what we want to do is we want to take a look at this example from the official docs itself. And let me just go ahead and minimize this so I can show you what's exactly happening. So for the sake of this video, I'm just gonna switch, let's say, I'm gonna switch back to legacy mode. For now, I'm gonna say react dom.render app inside of root, right? So the moment I do this, refresh this page, I'm in the legacy mode. Now pay close attention to what's happening here. We have a first component, component 1, we have a component 2, and we have this app, right? And this is the exported component. So you can see component 2 actually calculates how many times it has been re-rendered, right? This is just calculating how many times it has been re-rendered, right? And this count will update here every single time this re-renders. Component 1 does the similar thing. The only one difference, not two, is in these both of them is that when I click on this button called next in component 2, I do this update inside of a promise callback, right? And this is just a regular promise which does not has any major significance, but you can see I do this callback inside of the promise, this update inside of a callback, and inside component 1 I do this right inside the function. Now in the legacy mode, what you would see is something weird, that when I click on the component 1, which is this function, when I click on this, you can see the number keeps on incrementing and the re-renders also increment in the similar fashion, right? Why? Because right here, when I click on this button, although we have two state updates happening here, React batches them together and just performs a one DOM update, right? That means this function re-renders, this function is destroyed and called by React only one time, even though we are setting two state variables here. This is important because if there was an await call here, it would have been two updates, right? Which also makes sense because await can pretty much take any arbitrary amount of time in order to resolve a promise. But here, what you see here is that in component 2, even though these two calls are happening one after another, the fact they are inside of a promise callback results in the following code. So when I click on this, you can see we get 2 re-renders, not 1. Then if I click on this again, we get 4 re-renders, not 2, right? And so on. So you can see that in case I have a promise and I call a state update inside of that. So anytime you add more state updates, React will actually tear down this function and reconstruct it again and again and again on a single state update. This is bad performance-wise because now React is doing multiple renders where one would have sufficed, right? React 18's concurrent mode, opting into concurrent mode, fixes this. How? Because now if I go ahead and remove this and opt into the createRoot mode, which is our React concurrent mode, now if I go ahead and use the same code as before, this of course works just like before, but this right here also works like above, because now what's happening is that we are using this thing right here, automatic batching of multiple set states. Now the reason it says that it's a star because you can see that legacy mode has automatic batching in React managed events, but it's limited to one browser task. Non-React events, whatever, right? This just means that you will not be able to have React batching these set state calls inside of promises or inside of callbacks or anything like that if you're not on React 18, right? So this is just one video, one example of what createRoot will bring as a change to React. And there are interesting things here. I mean, if you try to look into suspense and suspense list is also interesting, where you can actually define an order in which the components appear on the screen, right? So we'll discuss that as time goes on and as more and more features become stabilized. But this is something I think was pretty interesting and pretty important, and probably something you should even know about as well, right? That if you use multiple calls of functions like this, you don't have to be afraid of multiple renders. React is smart enough to just batch them all together and do it in one go. Difference between React and React Native. And in order to understand this question, in order to answer this question, we have to dive deep into how JavaScript works. So let's go and discuss that in this video. Okay, so before actually discussing what React Native is and how it works, let's actually understand how JavaScript really works, right? So you have a browser. This is your browser window, whether it's a Chrome, whether it's a Firefox, it does not matter. The thing is, you have a JavaScript engine sitting right here. So whenever you write document, let's say document.createElement, right, or document.getElement by ID, or whatever you do, that goes to your JavaScript engine, and then this JavaScript engine is supposed to tell the underlying operating system what needs to be done on the screen, right? What do I mean by that? Let's say you create a button. Let's say you create a button using JavaScript on the screen, but on the page you would see on your browser, the button which appears is technically rendered by your browser, that is your Chrome or whatever, Firefox. But this work, the button rendering, is also done inherently. It's done by the operating system, right? There is a layer of JavaScript which communicates the following to the browser, right? Which communicates the following message to the operating system, right? So OS is finally able to draw the pixels, the graphics, it is able to shine those pixels on the screen that makes this button appear, right? So what is happening here is that, first of all, this document API is provided by the browser to the JavaScript world, right? And then the browser which renders the button, that button API is provided by the operating system to the browser, right? So this part here is super important because you cannot create a button on the screen without using document, and internally the browser cannot create a button on the screen without using some internal operating system API, right? So technically what's happening here is that JS accesses an API exposed by the browser, and browser accesses an API exposed by the operating system. This is how your JavaScript world works at the moment. So if you're writing something in the JS world, that gets directly called by the operating system or inside the browser using certain V8 APIs, right? So if you go to your console and if you try to write document.createElement or some native calls, native functions like them, and try to convert them to string, you're gonna see Chrome says something like native code or something like that. Why is that? Because that code is not invoking another JavaScript function. That code is invoking some C++ code inside of your browser, right? Which might invoke some operating system level code as well. So this is the architecture on how JavaScript works. Now you might think that React and React Native probably would have more in common as React than JavaScript. But technically speaking, React and React Native have only this part as common. That's it. That's just a single word. Let's just now see how React Native actually works. Alright, with React Native, let's see what's happening. Let's forget about React for now, right? So you have again a JS layer where you're technically writing a React code, but we're gonna discuss that later. Then you have a bridge, right? And then you finally have an operating system, which could be an Android, which could be an iOS, which could be pretty much, right? So what this React Native is doing is that it allows you to write certain JavaScript which calls certain bridge level APIs, which then calls the OS level APIs. Now, if you think about this is very, very similar to what we discussed how JavaScript internally works. Because if you have a phone, let's say if you have an iOS or Android or whatever, if you have a phone like this, it has its own operating system calls for drawing these buttons and stuff, right? So if you want a button on the screen, which is 20 pixels from the left, 30 pixels from the top, you're gonna have an operating system call, whether it's Java, whether it's Swift, Kotlin, whatever, right? When you do native programming, that is with Swift or Kotlin or Java, your app code gets compiled. So if this is your app code, this app code is compiled into something which directly calls these OS level APIs, right? For drawing a button, for doing X, Y, Z, whatever. So therefore you avoid this hop, right? Of calling it via a bridge. And this bridge is technically a bridge, right? It's a bridge where the message passing happens. I mean, you can technically say that it's kind of similar to a browser in a way, but a browser is a much faster way to call an OS level API compared to a bridge, because a browser does not serialize and deserialize your commands for the operating system, right? If you want to say document.createElement, the browser will not serialize this and send it to an OS. It will actually call the OS. So in that case, a browser is kind of not similar to this. But in an architectural level view, this is how it works. You write a JS function. A JS function is serialized, or that JS call is serialized and passed via a bridge to an operating system if required. And then the OS runs that and updates the screen however it wants to. Okay, so what is the point of React and React Native then? Let's also cover that very briefly. Now, if you understand, React is nothing but a fancy library for performing a tree diff, right? That's what React does at its core. So React does a construct of a virtual DOM, and it is able to see if a specific node or a parent node has changed or not. In this case, let's say both of them have lost their children. So therefore, React would optimally try to update the UI to this. Now, the way this happens on the mobile front is that people said that this UI can pretty much be also represented like a React Native tree, right? A tree-like diagram where you have all the application and buttons and nested things going on. And whenever somebody taps, the layout changes, the trees change, and so on. So what we do is on the JS level, the UI layer which we have, this UI layer is React, right? So whatever the changes are happening, the changes are communicated via a bridge which actually serializes and deserializes these calls. And this architecture is it's going to change with the new advancements in React Native. But at the moment, the way it happens is that this is a bridge which actually ReactJS calls have to pass in order to get to the OS. So this UI layer is updated just like it updates React layer on the web, right? So this UI layer is pretty much the same as web, right? So you can see this UI layer for the tree diffing is the same as web, and this UI layer is called the React package on NPM, right? So when you download npm install React or yarn add React, you are adding a React package to your project. Now, this bridge right here and some associated things as well, they come under a renderer, right? So you have a tree, you have the technology to diff the UI of certain trees, or diff the changes in certain trees, but you still need to convert this tree into this thing, right? It still needs to understand how the native platform operates or works. And for that, you need a renderer. For browsers, that renderer is called as the React DOM. Why? Because your DOM is also represented as a tree, but it needs the HTML. It needs the button tag. It needs the div tag. It needs all these tags, right? In React Native, we have the view tag, we have the image tag, and so on. Now, interestingly, when you write ReactJS for web, you directly use the HTML things, but because mobiles are not, for the most part, they don't have a HTML-like syntax, you still write custom, React-made elements, but these elements get transpiled into native views on their respective operating system, right? So if it's an iOS, whatever the view or analogous to div, whatever that did on iOS, that will happen on iOS, and similarly on Android, right? So this JS6 or whatever you're writing needs a way to transpile into this native view, right? And that is where this renderer comes into place, not React DOM. For this, it's actually called as React Native. When you install React Native package from npm, when you say npm install React Native, you're actually installing a renderer. A library is still React. This UI layer is still React. This part right here, this communication and the bridge and everything, which happens with the operating system and even some native files in this case, are provided by React Native. So this is the difference between React Native, and not exactly a difference, but technically how everything works when you're writing a React Native project. All right, let's start with React functional component. So React functional components was not the cool way to do components as long as there was not hooks, the concept of hooks introduced in there, because there was no state, right? But when the concept of hooks was introduced, then you can create actually functional, truly stateful components in React by just using function. Before that, we had to use class. So let's say this is your component like this in React, where we have a simple button, a state, and on clicking this button, we just have the counter incrementing, right? Now, what I want you to understand is what exactly happens when you click on this button. So what React does internally is, obviously, if you have also displayed this counter somewhere, you will see whenever you click on this button, the counter will increase from 1, 2, 3, 4, and so on. So you can clearly see X is changing, right? But this sounds a bit weird if you're seeing this for the first time and you see that you're using a const modifier here for declaring this X variable, right? That means you technically cannot do X equal to 2, or X equal to 3, or X equal to 4. You cannot do this stuff. This is not allowed because you are using a const. That means this X cannot change value. And sure enough, we don't even do that ourselves, but does React internally, can it do that? Well, of course not, because React is part of JavaScript. This is JavaScript, this is React. So obviously it cannot break the rules of JavaScript itself. So what React actually do in this case, when you're using a functional component, is that it calls this function again, but with a new X value. Now, let's see how that happens. So the way I like to imagine this is in a form of a React universe, right? So React has a small universe of its own where all these functional updates reside. Now, let's say this is the first function render which has happened, right, on the screen. So this is the very first render. That means you're seeing a 0 on the screen and X is also 0 in this React functional call, right? So the moment you click on this button, you click on this function gets executed. And what this is doing is that within that React universe, it's going to create another function, another new function. It's going to call this function again. But what's going to happen is that this time, when this function is getting called, this X, set X, you know that this set X is going to receive a function anyway from useState, but this function gets called in a similar way, right? This is the exact same line which happens as well. The only difference is in this universe, in this function of the universe, this expression right here returns 0, but in this universe or this iteration, this expression right here returns you a 1 instead of a 0, which makes all the difference, right? 1 comma the function basically. Because then the X becomes 1 and then set X becomes something else, right? So now in this part of the universe, the X value is 1. And then of course you have the set X as a function modifier as well. So what's essentially happening is every single time you call this set modifier, React renders that function again as a different part in the same universe and then replaces the useState value with a new one. Now, why this is important? This is important because you can very easily perform some weird behavior, especially when you use use effect or stuff like that. So we'll discuss about use effect later, but what we can discuss right now is that this useState right here, you can see, can now work even with following the JavaScript rules. Why? Because you can see I'm not mutating the value inside a function. I'm actually rendering a whole new function, right? And whatever this is returned, whatever this function returns in the second iteration, that actually gets created as a React, new DOM, right? So if this was the function which called it, it's going to be replaced, and this new function right here, which had X equal to 1 value, would be created, and then this would be compared with the original DOM on the screen, and React will say that, hey, we have update to this particular node, therefore DOM, please go ahead and update this, and this will appear on the screen for the user, right? So this is how functional components work, and this is why you are also able to use const within the functional components, because it does not mutate the variable, it actually creates a whole new function. There are very interesting use cases which happen when you use, for example, like I said, when you start using use effect and use effect plus set interval or set timeout. When you use this stuff, you actually understand how this behavior really works, how this transition really happens from one function to another and so on. But yeah, this is something for another day, maybe a bit of more practical instead of this theoretical understanding. But yeah, I mean, I hope that you got the idea how React functional components actually work. On every single state update, they create a new function, they never reuse the previous one, right? In an ideal world, this previous function should be destroyed and garbage collected and all that stuff. But a lot of times, like I said, this is one of the clearest examples where you can, just have this zombie function sitting right here, eating some variables, some memory resources, even running some side effects, possibly. So you don't want to do that. But yeah, like I said, that will involve a lot of use effect and, some tricks and tips. So maybe that's something for another video. All right, let's talk about SEO a bit, because I believe as developers, we don't have a lot of knowledge about this. So it's good to know about SEO, because when you're developing your own indie projects and if you want to get free traffic, I mean, Google is the best way to get that over a sustained amount of time. So SEO stands for search engine optimization, which means whenever you search something on Google or any other search engine, as a matter of fact, how that particular search engine, whether it's Google, whether that's Bing, whether that's DuckDuckGo, any other search engine, tries to rank the web pages it has indexed, that comes from how good the SEO score or any sort of score which that particular engine uses is for that particular website, right? So I can write how to learn React, but chances are codedamn.com isn't ranking right now for this, because codedamn would have slightly lower score than other websites which are ranking for this keyword, right? So over the long period of time, the Google or Bing or any other search engine would try to filter down which site is good for ranking at number 1, 2, 3, 4 and so on, and which site is not. So how does that work? Let's understand and why React or any client-side framework would not be able to help you in that manner. Let's take a look at a typical client-side application, right? So CSA is kind of like a short form for client-side application. So what you do is you write an app. Let's say this is a React application, and what React does, let's say you did a create React app. So what this would do is that it would spit out at least 2 files, which I'm pretty sure the first one would be an index.html and the second file would be a script.bundle.js or bundle.js or whatever, some sort of JS file. And this index.html links to this file, right? So what does this mean is that this index.html is just the bare bones HTML. So this HTML is the bare bone HTML, like I said, just to load this script, and this script start executing and create a rest of the things which you see on the page. For example, an h1 tag with hello world or whatever you have, but that stuff is done on the fly by this script bundle, right? This is how client-side rendering applications actually mean. Client-side rendering, basically CSR apps, mean as well that you send the whole JavaScript payload and the whole document is constructed on the client side. Now the problem with this approach is a search engine like Google, for example, they use something known as crawling bots, right? And these bots are just piece of software which are just crawling on the web, trying to index one page after another, trying to go from different site to site and reading their HTML, right? So Google, a search engine like Google, does claim that they execute JavaScript, but they defer executing JavaScript to a later stage, right? So it might be possible that Google crawling bot visits your web page, sees that there is pretty much nothing in your HTML except for a script tag, and it does not execute the script tag right away, right? Because it's reading the source code. It just sees the HTML and finds out nothing is there. Therefore, your page pretty much gets no advantage on the first crawl itself, right? Now, Google says that, hey, we go ahead and we execute the script later and we try to reconstruct and everything and, do the nice work. But I mean, there isn't a lot of confidence in the things which Google is saying for executing JavaScript, because we haven't really seen any client-side rendering application ranking on Google on a high volume keyword, right? Most of the people do prefer to have server-side applications because, I mean, for Google it's fine, but what about Bing or DuckDuckGo or any other XYZ search engine, which maybe like 5% of the world population still uses? I don't know the numbers, but you do want to optimize for this 5% traffic as well, right? So for that, client-side rendering option is not an option at all, because you don't get enough content in your first index.html page load. Or as a matter of fact, if you're on any route that pretty much sends index.html that loads this, then it'll load the router, for example, in React, and then just render the page, right? So this process, search engines don't have time for this, right? They want the page ready instant on the view source. The content should be there. To solve this issue, we have 3 options. The first option is pre-rendering. So what pre-rendering means is that you already have a constructed DOM once the page loads, right? The user can see the page, obviously. So why not, what the user sees, we just copy that whole HTML and paste it in a file and kind of, when the user first arrives, send the pre-rendered page instead of the client-side rendering and do the client-side rendering afterwards. Now this is different from server-side rendering. This is not server-side rendering. This is basically saying that, hey, I'm gonna spin up a headless browser like Puppeteer, and I'm gonna visit all of your pages on the website and create .html files out of them, and I'm just gonna keep them on my disk right? And whenever a page appears, a visitor is appearing, I'm going to send this index.html file, and then I'm going to send the client-side rendering bundle so that it actually works as well. Pre-rendering is the simplest, yet I would say, the least friction, but a little bit flaky as well kind of solution. But if you have a lot of pages and if you want to get started, this is, I think, a good place to start. One of the solutions is pre-render, I believe, prerender.io or something, you can Google, but this is what pre-rendering stands for, and you can have independent packages as well for this. The second solution is selective pre-rendering. That is, you keep your app just like you have for everyone, but you pre-render the pages only for people or only for the bots with the help of their user agents, right? All these bots carry a user agent, which kind of would help you determine if you want to send a pre-rendered page or a client-side rendering app. And this is also a solution if your prerender.io or pre-rendering is having a bad experience for the end user. If there's a lot of page, just whites and then comes back to life, or if there is any problem with pre-rendering, this might be a better solution. But this has small quirk, that is, you should not be having content differences between what you're serving to the bot versus what the user sees, because Google explicitly mentions that they do not want different content compared to the user, right? So you should be making sure that you are keeping the content same, which finally gets rendered for the user. And the third option is, of course, server-side rendering or server-side generation. Server-side generation, you might get a bit confused with how pre-rendering works, but there's a difference. Pre-rendering is just taking the output of the generated page by the client-side rendering app and then putting it in the HTML. Server-side generation is basically doing server-side rendering, but caching the response for a certain amount of time before you actually even regenerate it or not generate at all, right? Plus this involves hydration. And this is basically the legal and the nice and the clean way of doing pre-rendering, if you want to say in that way. So for SSG and SSR, I believe we all know the answer. The best solution right now is Next.js, using your source code with Next.js. The only problem with Next.js is that if you're trying to move your Create React app, you would be logged into certain conventions. For example, the file name is one of the biggest convention of Next.js. For the better of the worse, that file names are bound to the routes. So if you are able to overcome that, that's fine. You would be able to use a lot of advantages. But yeah, you might get stuck with 1,000 other things. If you have a custom Webpack, then would it work here or would it not work here? Because Next 11 and onwards also support Webpack 5. You might be stuck with Webpack 4. There might be a lot of issues, but this is definitely an option and definitely a solid option if you're starting a new project in today's time, right? And you want to focus on SEO from the very starting. So the gist of the video is that your search engines need a lot of content in the index.html, the first HTML file which the browser sees. Because they are lazy, they would either defer or not execute your script at all, which results in your client-side applications being blank, that is having a white page for these SEO bots. That means no ranking. If your bot sees a white page, that obviously they won't be ranking any content. So to fix that, you have a pre-rendering solution. You have a selective pre-rendering, which is better than pre-rendering, but a little bit risky because you are sending different content. And you also have the best solution available right now, which might have a bit of problems if you're trying to port a huge code base, that is using Next.js with the help of server-side rendering and server-side generation. Personally, we use Next.js for codedamn.com, so that is definitely a good option. But yeah, it depends on what you need. One thing which I have seen a lot of people asking in the comment section on YouTube as well as on codedamn is how they can properly master ReactJS. And to be honest, there is no one right answer to these questions. How do you master something? There is no one set framework for that. But of course, there are a lot of bad ways to do that. So we can definitely avoid that and follow one of the good ways. Okay, so before we discuss how to master React, let's understand a bit about what React in itself is. So React is a UI library, which is not a framework. This means that React in itself would almost always not be a complete package in itself to build your full web application, right? You will need a lot of things with React working with it, whether that's for basic stuff like HTTP request or, caching or some central store, to as big as like design systems and, what have you, anything which comes to your mind. So it's a library, it's not a full-blown solution like Angular. So this is why mastering React not just involves the library itself, but a lot of other things in the ecosystem as well. So we're going to start off by simply dividing this into three areas, three parts. The first one is the core React itself. So this part includes stuff where I believe you should be knowing and having a lot of clarity on these topics. If you don't have, you can take a step back and try to learn about them more. So especially with Reacts, right now, having a massive clarity on how hooks really work, not just how to use them, but what is exactly happening with hooks is especially useful, and especially with use state, use effect, and use ref. The way these three hooks work, if you know how exactly they work, what the use effect dependencies do, how the use state re-renders the functional component, and how use ref values can be mutated and can be, used as a single source of truth among all these different functional component state updates, which is done by use state. So if you know about these three hooks, you are probably much better than most of the React developers out there, because a lot of developers don't really know how the hooks really work and how you can make them work in a specific way, right? The best example how hooks work is try to set up some sort of timers using use effect. So try to create some applications where you delay the time yourself. So this could be something which requires, for example, let's say if I give you random bars on an application, then you have to build an application which sorts these bars one step at a time. So one step takes 1 second. I'm just giving you this as an assignment to check if you know React well or not. So you have to switch the position of the bar, just follow any sorting algorithm, merge sort, quick sort, whatever, and then swap them, do this complete exercise with use effect, use state, and timers, right? Set timeout, set interval, stuff like this. If you're able to do this nicely with all the start and stop controls and without actually your application being buggy, that you understand how use effect and use state will work. Because building an application with timers like this, which has the correct stop, start, and even unmount and mount behavior, would actually require you to have correct understanding of these hooks and how React functional components work. The second part over mastering React is the React ecosystem itself. Now this is the part where a lot of people miss out on what you need to know apart from React itself. Because like I said, React is a UI library. It's not enough in most of the cases to build everything in a medium to large size application. So in this ecosystem part, there are a lot of tools out there, but you have to pick or choose certain tools wisely if you want to save time. For example, if you are making network requests and you have backend, which is GraphQL, let's say, then in that case, Apollo GraphQL might be a better choice as a networking library. Otherwise, you have libraries like UseSWR, you have libraries like React Query, which is I would recommend React Query because this is a good library. Plus, we also have a codedamn course on React Query, so you can check that out. Similarly, for UIs, you can have Chakra UI. In React, you can have Tailwind, which is not specifically with React, but it's more popular in React world. You can also have Material UI, which is again something available right out of the box in React. So you can look at, there are a lot of UI systems, so you can pick one and try to work with that. Then in terms of server-side rendering this, you have frameworks like Next.js, for example. There is also one framework I'm hearing a lot about called Astro Build. So Astro Build is there. So, just knowing about these things as well for server-side rendering and performance. This is basically React, right? Everything over here is React. You just have to know a bit about the ecosystem in which you're playing. And then finally, I would recommend focusing a bit more on advanced React concepts as well. So advanced React would basically involve stuff like suspense, for example, React 18 plus basically. So suspense and server-side rendering and React server component. So stuff like this would go over here, right? So you definitely don't really want to jump to advanced React part, React 18 plus things. And React 18 plus sounds like, something which is actually, you should do later, but it's the version for React. So yeah, I mean, focusing on this advanced side of things should definitely come after the core React concepts and React ecosystem. But this is something I believe you should also know, because this is where the world would be headed in the next 1 to 2 years if React maintains its position as the top framework, one of the top frameworks. Libraries, don't kill me yet. But yeah, I mean, moving on to these React server components and suspense, this would be mostly used with Next.js itself, or similar frameworks out there. So know a little bit about more features which have been introduced in React 18, which will be introduced in React 18. Remember, it's still in alpha, and try to learn about them, whether that's server-side rendering, streaming support, React streaming support from server, and stuff like that. So yeah, I mean, there is a lot to learn within the React UI library itself. So you should not definitely be just overwhelming yourself. Take your time to get into the core React part, then the React ecosystem, and then moving on to the advanced parts. But I hope this video would be helpful in order to determine what things you should do. If you use these things, for example, and you have no idea how they work, it might be a good idea to just take a step back and learn about them in great detail. You can find all the links in the description for these specific courses on codedamn's full stack learning path if you're thinking to master React this year before 2021 ends. React is building a compiler. Yes, that's the headline, and this headline came from ReactConf, which happened a few days ago, where one of the Facebook employees, Shun, actually gave a pretty awesome talk on what this compiler might look like in future, what this would do, and where the direction is headed towards. So what is a compiler exactly, what this functionality wise is doing, how this would be helpful to you as a developer, and what you should know about this. Let's discuss a little bit about that in this video. Alright, so before actually getting into what React compiler would do, this particular thing, which is named as a React Forget in the alpha stage right now, let's actually understand what React does right now. So whenever you write your React code, you would have seen you are using something like Babel, or the cool kids now are using SWC, for example. And even if this is in JS or TypeScript, you need kind of that transpilation, because you want to convert that JSX syntax into something which is JavaScript, right? JSX is not technically JavaScript. It's a HTML looking like structure, which uses a lot of JS. But still the browsers don't understand that. So this step over here is transpilation. So when this particular step happens, technically the code which you get, the bundle which you actually ship to the browser, it's still what you exactly wrote, logic wise and functionality wise as well, right? So the logic, the functionality is pretty much preserved over here. What React just proposed in the ReactConf with this compiler over here, this compiler right here, once this runs, it will perform certain optimizations in your code, and the resulting bundle which would be generated would functionality wise would remain same, and I'm putting an asterisk here because the code would be changed. The logic would also be, obviously, if the functionality is same, logic plus functionality would be same. Code level things would be different in a way that the performance get a lot better, a lot better. I mean, it really depends on app to app, how complex the app is and how much performance that could extracted out. But for example, the demo app which the Facebook engineer showed, that was doing something like 300 to 400 renders on a single click, and that just pretty much dropped down to 1 or 2 renders, right, because of that performance thing. So let's discuss what this performance hack is, what is this particular compiler doing, and how does this help in a React based scenario. Alright, so this compiler over here, which has been code named as React Forget, basically in a nutshell, what we know from the conf, what it does is that it memoizes pretty much everything in your React component. And this is important because why this is not happening automatically and why a compiler is needed for this. So you see, when you write a basic React app, let's say you are creating an interface like codedamn's playground, right? In our playground, you know that here you get the browser, right? You get the terminal at the bottom, you get the files over here, right? And you have the Monaco in the center, which allows you to interactively play and learn with code, right? So the codedamn playground, when you click on this single file, you would see that the Monaco editor actually gets changed, and the highlighting over here gets different, right? It gets highlighted to that particular selected file. Similarly, when I click on the next file, the same thing happens. When I click on another file or open another folder, that folder opens, right? Now, internally, what we do use is that this particular thing over here is an Explorer component, right? And what's happening right now, if we don't use memoization, is that on every single click, this whole file structure is recomputed, this whole tree is recomputed, all the elements are re-rendered, and everything, you would not be able to see it yourself on the screen, but we know that everything is re-rendered even if it is not changed, right? So if you have 4 files like index.html, script.js, and if you have a folder like assets, and here you have, let's say, file.jpg, and let's say this folder is collapsed initially, when you click on this folder, these 2 divs would also get re-rendered, right? Although they were not required to be re-rendered. Similarly, let's say if this was a complex tree of file structure, right? And if I open a nested folder, maybe something like node modules or somewhere, and I continuously click on that, I don't want every single item to be re-rendered, right? So in order to avoid that, what we say is that each component is memoized, but on certain criteria, right? It is memoized only as long as nothing is being done to this particular component, right? In this case, this particular Explorer also has this as the file component, this as the folder component. So our only parameter which we want to optimize against is that whether this is active or not, right? So if this index.html is active, then it has a different color. If this becomes inactive, then we want to re-render it because we want to change the color, the classes have to be removed and so on. So only that active prop is what we need. If on a click, there is no change in the active prop, we don't want to touch it, right? This is what I know as a developer, right? But when I'm coding on this application, React does not know this. React would assume that I need to check heuristically whether this div needs to be re-rendered or not, whether this div needs to be re-rendered or not, and it will try to do it for every particular thing in that component where something has happened, right? Now, if we talk a little bit about this, what components are essentially in React are now functions, right? So you have a function which takes certain input as props and return JSX. So what these guys have done is, at least what I believe this compiler assumes, is that this function is functional component, number one, super important. And ideally, this function is pure, as in it does not do any sort of side effects outside of that particular function, right? So this is my assumption of how what would be some of these requirements for React Forget to work properly without introducing any sort of bugs or anything. It should be functional and it should be pure component. And the way it works is that React compiler would actually take a look at all the props which are being used over here, and it will create a memoization of those components. So it will create this memoization. It will say your function call, and it should only be triggered when, let's say, prop 1 is changed or prop 2 is changed, because it is able to see that you're only using prop 1 and 2 in that particular function. The moment this happens, you get massive performance gains in an application as complex as, this, where you have multiple re-renders happening. Why? Because now you are not re-rendering anything at all on DOM, right? Which is not required. The best part about this is that all of this would be abstracted away from you. You would still write the code, which would just look as nice as you can see on the screen, but is actually transformed into a memoized version of component, which looks much uglier, but is much performant. Now, this sort of optimization is something which Svelte does by default, right? Remember, in the Svelte versus React video, we talked a little bit about how Svelte uses magic in a way that it takes a look at assignment operator and then figures out whether that's used in HTML or not. And if the variable is used in HTML, it will attach those certain triggers. But because Svelte is a compiler, it's not a library, it has much more information when it's compiling that code down to JavaScript, right? Because compilers can get into abstract syntax tree and private variables and take a look at what exactly is happening on a static analysis without running the code. And that is like the thing you need in order to perform this sort of memoization, which Svelte does by default, and which hopefully React would also start doing by default in some time. This feature, as said by the developer, is not production ready. It's not even, I think, available at the moment, and it might be dropped, but there would be something good which would be coming out of this new React compiler.
First of all, React is obviously something you need to know before you start getting into React's ecosystem. So the first peer dependency, if you want to say it that way, is React itself. The next thing which I feel is important for a lot of people here is to understand about the new context API. I'm saying new, but it's been a while for now, which is a very suitable replacement for a lot of common Redux usage, right? And I'll tell you another library in a while, which is also a replacement. But Redux in general, what it does is that it centralizes your state somewhere so that your components in the component tree don't have to do a lot of prop drilling and doing any sort of thing, and they just approach that central state, which is the Redux store, and just get whatever they want. Similar functionality also exists in context as a React context API. So make sure you understand this, because Redux is relatively heavier, and if you have something inbuilt in the library itself, then why outsource that if that can be done? Another thing which is also popular is React Query, which also trims down a lot of your Redux code. And I will say there is an alternative to this, which is use SWR library or Apollo GraphQL client as well, but that becomes relevant if you are using Apollo GraphQL on the backend. But anyway, my recommendation here would be React Query, but you can pretty much stick with use SWR as well. I'm just underlining my recommendation over here. So what React Query would do is, just like you would have these central store as the data, suppose if you have a dependency on the server for data. So instead of like making a call directly to a component and then doing a prop drilling of all the data into different components, what you do is let every single component make their own call and let React Query sit in the middle and handle those calls for you. So if this component, for example, makes a call which this component has already made, then React Query would intercept that and would not make the same call again and would just automatically give the data back to it, right? So it's kind of like Redux, but optimized for network request. And yeah, I mean, it's just a better way of making HTTP or network request in today's time. The next thing in the React ecosystem I would recommend is Tailwind CSS or Material UI. Now again, this is something which will depend on person to person. If you want to work with Material UI, that's fine. If you want to work with Tailwind, that's also fine. My recommendation here is to start with Material UI, but also consider Tailwind. So because we use Tailwind at codedamn, I'm gonna go with codedamn as a recommendation because obviously I'm biased. We do use parts of Material UI as well, but Tailwind gives you more freedom to do a lot of things, right? Which Material UI apparently does not. The next thing I would recommend you is to actually also use Next.js as a React developer, because this is also like a technology itself. There is, of course, another player coming up very soon, that is Remix, but still my recommendation is all my bets is on Next.js because they are like way ahead in terms of ecosystem and what they have done over the last few years. So Next.js is definitely my recommendation, but keep an eye on other frameworks, specifically on Remix as well. Next up, I would say TypeScript is also something which should be thrown into the React ecosystem. Very important to know if you're working with medium to large size projects. You can skip TypeScript for smaller projects. Don't use it for smaller projects. It's usually an overkill at that point, but you want the benefits to be there when you start increasing the size of the project, right? For general charts and data visualization in React, you can also use this library, which I discovered called Nevo. There are a lot of graphical solutions out there for React, but this is something I like because it's simple, straightforward to use, and also comes with TypeScript type support. So that is also awesome. And it's not low level enough that you will be lost in configuration itself, but not even high level enough that you won't be able to customize this a lot. So it's like a perfect mix of all the aspects you want as a developer to just quickly put a graph on the screen. A couple of more recommendations I have. The first one is for testing your code. So for testing, I would say React testing library is obviously the most popular out there, but there is also Cypress, and in this case I won't have a specific recommendation. Why? Because both do a little bit different testing. So it's end-to-end, and this is like integration testing. So basically both are my recommendation for this. But yeah, I think if you want to stick to something, Cypress is a better one because you end up testing as a user. If you set it up correctly and if you have a nice code coverage and all the tests written in Cypress, that's usually a better indication how stable your application is. In terms of checking any breaking features or anything, of course, React testing library would also be helpful if you want to just test some critical parts of your app. And finally, I would recommend to throw in a tool like Sentry as well in your dev bucket for doing error processing on front end, right? So if you get any sort of crashes or something is happening and you want to know what those errors were, what those crashes are, where they arrived, and so on. So setting up Sentry in your code base should be relatively simple once you understand its importance and why that is needed. So yeah, that's pretty much it for a power tech stack of a React developer. Let me know what you think about these technologies. If I missed something, do let me know in the comments below, or if you have some more recommendations, happy to discuss on that as well. That is all for this video. If you liked it and learned something new, make sure you leave a like and subscribe to the channel. Thank you so much for watching, and I'm going to see you in the next video really soon. If you're still watching this video, make sure you comment down in the comment section, I watched this video till the end. Also, if you're not part of codedamn's Discord community, you're missing out a lot on events which we organize on a weekly basis to code. You already know the drill. Make sure you like the video, subscribe to the channel if you haven't already, and thank you so much for watching.